Hello students, today we solve one question based on refraction of light through a glass prism. The question is, a light ray enters through a right angle prism at a point P with angle of incidence 30 degree as shown in figure. It travels through the prism parallel to its base BC and emerges along the face AC. The refractive index of the prism is. In the question, the angle of incidence is given and the refracted ray is along the base BC and the emergent ray is along the face AC. We need to find the refractive index of the prism. We consider the refractive index of prism as mu and we apply the Snell's law at a point P. We get refractive index of air into sin A equal to refractive index of prism into sin R. Here the angle of incidence is 30 degree, that is given in the question, and refractive index of air equal to 1, sin 30 degree equal to 1 by 2. From this we write sin R1 equal to 1 by 2 mu, and we know angle of prism equal to R1 plus R2. Here angle of prism is 90 degree. From this we write R2 equal to 90 minus R1, and we apply the Snell's law at a point Q. We get refractive index of prism into sin R2 equal to refractive index of air into sin of emergence. Here angle of emergence is 90 degree because the emergent ray is along the face AC, and sin 90 equal to 1. And instead of R2 we substitute 90 minus R1. So we get mu into sin of 90 minus R1 equal to 1, and sin 90 minus R1 equal to cos R1. So we write mu into cos R1 equal to 1, and instead of cos R1 we write 1 minus sin square R1 from the formula sin square theta plus cos square theta equal to 1. We already found sin R equal to 1 by 2 mu. So sin square R becomes 1 by 4 mu square. We get mu into root of 1 minus 1 by 4 mu square equal to 1. If we square on both sides we get 1 minus 1 by 4 mu square equal to 1 by mu square. When we solve this we get 1 equal to 5 by 4 mu square. From this mu square equal to 5 by 4 and mu equal to root 5 by 2.